We're going to have to go through these fast, so bear with me. So there's been a lot of recent work that's shown that there seems to be actually active tectonics on the moon, which is very different from what people were thinking of before. And we, as part of the recent PRISM work, did a pretty detailed look at the Gruithuysen Dome region, and we found a place that we think shows very clearly active tectonics. I'm going to go through this very briefly. We presented this at the LPSC. Here's some context for it. It's about 2 to 3 billion years old. The particular thing that we think is active is this so-called gamma pit here. We think this may be a collapse feature. Here it is blown up. This whole thing is down low here. This is the lowest point here, what I call the East Bend, which looks sort of like there's a block there. This is a highland terrain here, and it's surrounded by fairly recent, for Mare terrain, and these interesting concentric rings here. This is an oblique view from LRO. You can see that there's about 250 meters of topography change here, and about 750 meters from here down to the Mare surface, or about a kilometer down to the deepest part, which you can't quite see down here. And this is the edge of the Mare edge of the scarf. You can see there's a huge difference between the fairly typical looking with craters and small craters and so on, Mare surface, and then you go into this, the pit itself, and it's just full of craters. And then if you look down at the bottom of the pit, this is the lowest part of the pit here, right here where these dimples are. You see here's a boulder that's been rolled down fairly recently, the recent past. There are these dimples that are right at the join between the Mare surface, which is down below, and the highlands scarf, which is up above here to the left. It looks like, I mean, what are these things? Are these like outgassing was here, or maybe there was a sump here? Something's been going on here fairly recently, and this is the topographic flow because there's hole-in-one type boulders that have rolled down into the very dimples. So what could we do with this? This feature was first described in the literature, as far as I can tell, by Braddon and Robinson back in 2011 as a constellation target. They called it the negative topographic feature, which I think is a little too similar to, well, some recent financial stuff, so I'm not going to use it. So I call it the gamma pit. We call it the gamma pit. It's about 2 by 1 by ½ kilometer. So that's about a kilometer squared of a cube rather of stuff. That's a lot of stuff to go missing. And I looked around in Apollo images and so on from the surface, and I found this one from Apollo 15. This is the Hadley Rill from the elbow region, looking north, I think it is. And this is, I think, similar to what you might see if you were on the surface looking into the gamma pit. This is a rough area, as you can see. How would you instrument this? Well, we've been working on ballistic penetrators, and I'm going to go through them just a little bit. And they're about 1.5 kilograms. We have a standard instrument package. We're working on developing more. And the idea is, at present at least, that they would be deployed from a CLPS lander during its landing sequence. We've been talking to NASA Flight Opportunities Program to try and get that tested with some of the CLPS landers. Unfortunately, we had a lot of detailed discussions with Maston. I'm not sure that's relevant now. Here is a penetrator at ballistic testing. Ballistic testing means we get to fire it out of a cannon, which is actually a lot of fun when it works. And this is actually, just before a test, this is actually a live penetrator. There's actually a geophone in there, a computer in there, so on and so forth, LoRa communications. This thing is actually ready to go. Here it is being shot. This is a fairly slow test out of the cannon, which you see on the left here. And here it is. This is a very slow test. Here it is sticking up out of the ground. The slowness is why it didn't go too far into them. They typically go about a length into the ground, and at least in the, well, this is not lunar simulant. This is just a berm we have. And this is a sort of artist conception from Paul Blase of how it looks how it would look in the ground, probably tilted in reality, but you have the head nose cone, which is hard metal. You have a geophone that's fitting in a little hole in the nose cone. This works fairly well. You have electronics, which are potted so they survive. You have a battery. You can have more instruments up here. You could have, we've been working on electrical properties experiments. We've been working on, we could have a camera there, maybe even a mass spectrometer. We've been talking about that too. and you could shoot these into the ground. And what would you do with this? Well, here is a view of a deployment sequence, assuming eclipse landing on the Highland Peninsula, not the Gamma Dome itself, but the peninsula next to it. Now, this is not what they've chosen to do with PRISM, obviously, with the deployment, the task order for for Gruthuysen region. They're going to land on the dome itself, but you could do this. You could land on the peninsula. You could let go of the penetrators about 70 seconds or so. Well, their flight time is about 70 seconds, about 2 minutes before you landed, and they would flow down into the bottom of the pit, and they would have a pattern looking like this. And this is actually from numerical, this is gravity in here. This is actually like, this is a flight sequence here using the actual lunar gravity and so on. And this is what it looks like on the surface. Now, I think in reality, they would not be so neatly arranged. It'd be more of an irregular pattern, but I think you could do that. And you see with a kilometer width and about with a kilometer length rather, and about a half a kilometer width here, you could get a fairly decent distribution, onto this, both the Highlands area, the
2 minutes, Marshall.
Thank you very much. And even up into the Mare itself. So you could sample all these different terrains. And then the idea is the thing is going to, if it's active, if it's still active, if it's still producing anything like moonquakes, you'll see motions. You'll see post or aseismic motions, maybe even seismic motions if you're lucky. You will hear the seismometry will be able to tell you what's going on beneath the surface. And if you can sample the volatiles coming off, you can tell what's happening, like if you're moving rocks around, does that release volatiles? You could actually do that. And so in conclusion, I think active tectonics are going to be a really fascinating thing to study on the new moon, if I can call it that, the moon 2.0 that we're going into here. The fresh boulder fields, I think, are the real signature of that. I think the gamma pit is definitely an active feature. I don't think it's a thrust fault. I don't see how it can be a thrust fault. And so it's a new form of feature, maybe a recent collapse, maybe something else. And I think these things need to be instrumented. We know how to do this on the Earth. We can take the stuff we've done, including me, have done on the Earth, and apply it to the moon. And so we're looking for collaborators on this. And any questions, I'll be glad to take them. Thank you.